Complete the Venn diagram to show the relationship among integers, rational numbers, natural numbers, and whole numbers. Move the correct answer to each box. All right, so let's think a little bit about what these are. Your natural numbers are the numbers that you start counting with when you're little bitty. Like think back to when you were 2 years old. You would go 1, 2, 3, 4, 5, 6, and so on. And you would be so proud that you could count. Those are the natural numbers. Whole numbers are all of those natural numbers and the number 0. So now we have 0, 1, 2, 3, 4, 5, 6, 7, and so on forever, right? You notice that I don't need any decimals right now. I don't need any negative values or percents or fractions or any of that. I can write these numbers just with one digit, right? And without any special notation or anything like that. These are fairly simple. We're going to make them a little bit more complicated when we talk about integers because we're going to allow them to be positive or negative. So now we've had all of the positive values and 0. Now we're going to have their opposites as well. So I've got numbers down on this side and then -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Oh, I'm running out of space, but you get the idea. It's all of the whole numbers and their opposites. So it's the positive and negative integers and 0. So those are my integers. And then things get really complicated when we start to talk about rational numbers, because rational numbers include any number that can be written as the ratio of 2 integers. So for example, 3/2 is rational because I can write it as a ratio of 3 and 2. Let's see, 1/3 is rational because I can write it as a ratio of 1 and 3. -3/2 is rational. -1/3 is rational. 25% is rational, right? All of these are rational. Now, one thing to keep in mind, and I'm not going to list more rational numbers, just know that there's a whole lot of them. One thing to keep in mind when you're thinking about rational numbers too, is that sometimes you could write a number in a simpler form than it's given to you, right? So let's say that I have the number 9/3. Well, 9 divided by 3 is 3, right? Remember, a numerator over a denominator is another way of representing division. So 9/3 is really 9 divided by 3. So 9/3, it might look like a rational number, and it is rational, but a better classification for 9/3 is actually a whole number because it's equal to 3. So 9/3 would actually go down here. Oh wait, no it wouldn't. It's a whole number, but the better place for that to go is down here with the natural numbers because 3 is a natural number. In fact, we see it right here. Now, what if I had -10 over 5? 10 divided by 5 is 2, so this is -2. So -10 over 5 would go in my integers list, right? In fact, -10 over 5 is really the same thing as -2. So that's an integer. It looks like it is written in a fractional form right here as a ratio, but it would be best classified as an integer because it can be written just simply as -2. Okay, so now we know what these are, and we're ready to place them here. We have our natural numbers as our smallest set. Then we have our whole numbers, our integers, and then our rational numbers. Okay, so what this means is that all natural numbers are whole numbers. All whole numbers are integers. And all integers are also rational. So if you belong to an inner set, you also belong to the outer sets that encompass that set.